Welcome back, students. Now we are going to continue second type of evidence, part 7, corresponding elements of two congruent triangles. Property: if two triangles are congruent, then all their corresponding elements must be equal. Example: in this adjacent figure, ACD and BDE are two congruent triangles. Deduce that angles ADC equal EDB. So here we have the fact that these two triangles are congruent. Prove that ADC equals EDB, question mark. Once they gave us the information that these two triangles are congruent, we can claim that all their 6 corresponding sides and angles are equal. But here, since we only need one of them, we only use the fact that these two angles are equal. Proof: triangles ACD and BDE are congruent, then all their corresponding elements must be equal. But here I only name these two because I only need them to answer the question, namely ADC equals EDB. So we need to memorize this sentence because it's very important. Or you can also say, in particular, ADC equals EDB. You write one of them. Important remarks. In the example above, we don't have to prove that the two triangles ACD and BDE are congruent because this information is already given in the form of text inside the example. The expression in particular and the term namely have the same meaning. Given in this example, the fact that these two triangles are congruent means that you have the right to claim that their 6 corresponding elements, angles, and sides are equal. But since we only need one in particular to answer the question in the example above, that's why we only name, namely, the corresponding elements that are needed. No need to name the other 5 elements. We only named ADC equals EDB in the example above. Now part 8, angle bisector properties. Remember, the bisector of an angle is a semi-line that divides an angle into 2 equal adjacent angles. Let's remember, this blue line is the bisector of angle BAD. It divides this angle into 2 equal adjacent angles. And here, if you have a straight angle, this bisector is perpendicular to both sides and 2 right angles are formed. Example: in this adjacent figure, BP and CP, these two semi-lines, are the bisectors of angles ABC and ACB respectively. It means BP is the bisector of ABC and CP is the bisector of ACB. We follow the same order. Write all the possible evidence that we can claim and state the reason. Remark: we can also say BP bisects ABC and CP bisects ACB. So here in this figure, we can say that angle ABP equals angle CBP, angle bisector effect. So here also the reason is not given. It's not a straightforward evidence. We deduced it from the definition of the angle bisector. We can also claim the fact that ACP equals PCB, also same reason, angle bisector effect. Reminder: the intersection of the 3 angle bisectors in a triangle is called incenter. If we draw the 3 angle bisectors, their point of intersection is called incenter. Remark: having 2 angle bisectors in a triangle is enough to find the incenter. The intersection of 2 angle bisectors are enough to find the incenter. So P is the incenter of triangle PAC. intersection of the two angle bisectors BP and CP in triangle BAC. Attention, AP is the bisector of the third angle BAC. So since P is in center, we can easily deduce that the semiline AP is in fact the bisector of angle BAC. AP is the bisector of angle BAC because P is the incenter of triangle BAC. So we can claim the fact that BAP equals PAC angle bisector effect. Calculation notes. When you calculate the two equal angle parts of the bisected angle, we divide the angle by 2 to find these two equal angle parts. For example, if we want to calculate APB and PBC, it's equal to angle ABC divided by 2. Angle bisector effect. Also, ACP equals PCB equals ACB divided by 2. Angle bisector effect. Also, BAP equals BAC equals BAC divided by 2, angle bisector effect. Now, part 9, complementary, supplementary, and vertically opposite angles properties. Now let's start with complementary angles. Two angles or one pair of angles are complementary if their sum is 90 degrees. So they add up to 90 degrees. Let's watch this animation here. These two angles, if you put them next to each other, they form a right angle. Now let's change their measurement. If you see, they are equal to 90 degrees. Their sum is 90 degrees. If you notice, the pink angle and the blue angle are in fact adjacent and complementary because they have same vertex, they have a common side, and they are situated on opposite sides of their common side. These are two adjacent supplementary angles. Two adjacent complementary angles form together a right angle. So the pink and the blue angles are complementary. Two right angles are never complementary. So be careful because 90 plus 90 equals 180 degrees. It's wrong. Important vocabulary. If two angles are complementary, each angle is called or represents the complement of the other. It means, since this pink angle and this blue angle are complementary, it means the pink angle is the complement of the blue angle, and the blue angle is called the complement of the pink angle. Each one represents the complement of the second. Supplementary angles. Two angles or one pair of angles are supplementary if their sum is 180 degrees. They add up to 180 degrees. So these two angles are supplementary, but they are not adjacent because they don't have same vertex. So here let's glue them together. When you glued them, they formed a straight angle. Here you have two right angles. We glued them together. They are equal to 180 degrees. So it doesn't matter what is the measurement. Two supplementary angles, their sum is always 180 degrees. These two angles are only supplementary. They are not adjacent, but these two angles here, this pink angle, this and this blue angle, they are adjacent supplementary angles. Two adjacent supplementary angles form together a straight angle. Important vocabulary. If two angles are supplementary, each angle is called or represents the supplement of the other. Here the pink angle is the supplement of the blue angle, and the blue angle is called the supplement of the pink angle. Each angle is the supplement of the other. Now let's continue with vertically opposite angles. Two angles or one pair of angles are vertically opposite if they have same vertex, and the extension of the sides of the first angle are the sides of the second angle. Here, if you notice, the two red angles are vertically opposite. Here in this angle, if you extend both its sides, you obtain the second angle. Same for these two green angles. If you extend the sides of this green angle, you obtain the sides of the second green angle. Another meaning, it means that they are the pair of angles formed by the intersection of two straight lines. Here, the two intersecting blue lines, they form two pairs of angles, two acute angles and two obtuse angles. And in this special case, when they are perpendicular, they form four right angles. Let's see, and these two pairs of angles, the acute ones and the obtuse ones, are vertically opposite. So if you notice something here, the pair of acute angles, the red angles, are equal, and same for the green angles. Here, this special case where the two lines are perpendicular, four right angles are formed, and the four of them are equal to 90 degrees. Now let's rotate the two lines. Also, the two obtuse angles are equal. Also, the two acute green angles are equal. So very important property regarding vertically opposite angles are always equal. This is a very important property. Example, in this adjacent figure, lines QT and SR intersect at P. In this figure, although we have the segment QT, but when I say line QT, it means the line passing through the 2 points Q and T. Sometimes we draw the part of the line that is only needed. Write all the possible evidence that we can claim about the corresponding elements in triangle QPR and STP and state the reason. So in this figure, we don't have any straightforward evidence nor in the text. But the only information that I can see here is related to the two intersecting lines QT and SR. And I know that vertically opposite angles are formed by two intersecting lines. So I can claim in these two triangles the fact that angle QPR equal to angle SPT because they are vertically opposite. So solution, a QPR equals angle SPT. The reason here, it's not a straightforward evidence. I cannot write given. I used the property of vertically opposite angles, the fact that they are equal, and which is a very important property. Now, question B, can we prove that the two triangles QPR and STP are congruent? Why? So here I was only able to claim one evidence. But in fact, to prove that two triangles are congruent, I need three evidence at least. So of course I cannot prove that these two triangles are congruent because there's not enough evidence. So B, no, we cannot prove that the two triangles QPR and STP are congruent because there is not enough evidence. Only one evidence can be claimed while we need three. So attention, we cannot claim an evidence that is not given or that cannot be proved. So I cannot claim any corresponding angles or sides other than these two, because here they mentioned that these two lines are intersecting. I cannot claim any other evidence. So this is the end of part 4. We finished till now 4 parts. These parts were somehow easy because we remembered properties that we learned earlier last year and this year. And the next coming parts, you will notice that things will be a bit harder. It will be more analytical. The strategies that I will be using, they require more critical thinking. So see you in part 5, and thank you for watching.